We are going to do our last exponent rule, which is on slide 16, raising terms with exponents to a power. So we are going to do this in our journal. So go ahead and title the next page in your journal, raising terms with exponents to a power. No, I don't want that to open. I don't know what I'm thinking. Our first problem is, let's put in parentheses, 3 times 3 to the second power. All right, so how do we do this? Remember order of operations, what did I say to do first? Parentheses, yep, so 3 times 3 is 9. Then we do 9 squared. 81? Y'all good with that one? And let's do 2 to the third power raised to the second power. If we follow order of operations, what would we do?
2 to the third power.
Okay, and what would that be? 8 squared? What does that equal? 64. Okay. Is there another way to work this out? You think it's 2 to the 5th? What does 2 to the 5th equal? That's 32. So that can't be right. What would it be?
6.
Okay, so how could that equal 2 to the 6th? Okay, so possibly multiply those. Yeah, because that comes out to 2 to the 6th. All right, so let's just look back and think on, what does squared mean? Repeated multiplication. So for this one, what will I multiply together? Let's just think about the number inside is repeatedly multiplied how many times? No? 2 times. Yeah, it's confusing, right? Because you're like, 2 to the third is 2 times 2 times 2. It's 3 times. But 2 to the, but whatever's inside squared means that times itself. So I could rewrite this 2 to the third squared as 2 to the third times 2 to the third. So what would that end up being? What operation do we do with our exponents whenever we multiply like terms, like bases? Add them. So what would this be? 2 to the 6, which we know equals 64. Okay, what about the next one? A squared to the 6th power. Let's expand this out like we did this one. If I expand it out, what would I have? A2, how many times?
6.
Okay. And then what do I do with that? Multiply what? A2. Okay, so what do I do with exponents then? Add them, yeah. So 2, 4, 6, 8, 10. Let me pause this real quick. So then that would be 2, 4, 6, 8, 10, 12, right? A12. Are you seeing some kind of pattern that we can do an easier way? Like what we did up here? Yeah, just multiply. So if it's A2 to the 6th power, be A12. So what is different about this versus this? One's easier. Faster, okay.
You've done just A4 twice. Instead of writing it all out. I know. A like
A4, you could do, say that again?
Like A to the 4th power, since you multiply 2 and 6 is 8. Couldn't you have done that? Or no?
You could do A to the 4th, how many times?
Just twice.
No?
Or,
It'd be 3 times.
okay.
Yeah, which still comes out to 12. So the difference between, let's say, A2 times A6, what is the difference between this and this?
Because you add the two exponents with
You-
the bottom one.
You add those exponents, because what's different about this?
That one is in parentheses.
This one has parentheses. How many bases does it actually show?
One.
It just shows that one. But this one has 2 because you have a squared times a6. This means addition. But this one, what is that going to mean? Multiplication. So our rule for raising terms with exponents to a power, what are we going to do with the exponents? Multiply them. Multiply. Y'all caught on to that really quick. So let's do another one. 4 to the a power to the 3rd power. So I have an exponent that's a variable and an exponent that's a number. What are you going to do with those?
4A.
Well,
4a, 4a, 4a. And then what do you do? Those are a's. They look like 9s. Those are definitely a's though.
Would you multiply the base?
Mm-mm.
Well, or do you add the bases?
You would keep the same base. So we expanded this out. So now that it's expanded, see how we have the 2 bases? But this time we have 3 bases. What do we do with these exponents?
Or do you add them?
Add them. So what would that be?
4A to the 3rd? Oh, wait, that's the same thing.
No, 4a plus a plus a, right? Which equals, yeah, 4 to the 3a. Was there an easier way? Yeah, what would it be? Just multiply a times 3, yeah. Just multiply those. 4, a times 3, which we always put the number first, so it'd be 4 to the 3a. Why did this trip y'all up, though? Because that variable in the exponent, yep. Did you know that you could switch these around and you could actually do 4 to the third to the a power? It would be the same thing, yeah. What this means is 4 to the third times 4 to the third, 4 to the third. How many times? A times, right? Which is confusing because it's a variable. But you're still adding 3 to itself a times, which we could just multiply these two. 4 to 3a. Yes.
Can you have an exponent like 4 an exponent?
Yes. So like b to the a squared. Is that what you're saying?
Yeah.
Yeah, you can have that. Which is kind of crazy, right? Because this would be like if I did b to the a and then a with the squared out here, or another example would be like 5 to the 6 squared to the 5th power. Yeah, isn't that crazy? But yeah, you can have exponents. Just like you can have fraction on top of a fraction. Even though you have a fraction numerator denominator, you can have a fraction in the numerator. You can have a fraction denominator.
But why would you just have to simplify them first?
Yeah.
Simplify it.
Yeah, so this one would be 5 to the 6/10, because you would multiply those two. And then you'd find what's 6 to the 10, but that would be a really big number. So we'd probably want to leave it like that. I know, it's kind of crazy. Hey, you asked for it. I wasn't going to teach that, but you asked.
When did we learn that?
You might be using this in Algebra 2, Pre-Cal, Calculus.
Yeah.
Yippee. All right, so let's do, if I have 3a squared to the 3rd power. What is the 3rd power of? But what about this 3 out front? Is it also with that? Yeah, because what this really means is 3a squared, 3a squared, 3a squared. So a common mistake is that people just do the a to the 6 and it's 3a to the 6. But you can't do that because the 3 is also being cubed. So this ends up being 3 times 3. Remember how we can reorder things? You don't have to because we can see it right here. Just 3 times 3 times 3. So that's really 3 to the 3rd. Do y'all remember what that one is? 3 times 3 is 9 times 3 more. 27, yeah. And then what would the a be? A to the 6, yeah. So using our rule that we learned, how would we do it without expanding it out? Because what if this is like exponent of 50 or something like that? Something crazy. How could I expand this out? I mean, do it without expanding it.
So 3 times.
3. That's like to the 1st power, right? So it'd be 3 to the 1 times 3 is 3. And then 3 to the 2nd power. I mean, a to the 2nd power times 3 would be to the 6th power. So you just have to make sure that you take that exponent to every term inside of that parentheses. Don't skip the constant. So, of course, 3 to the 3rd is 27, and then a to the 6th. Same answer, just one we expanded out, the other one we used the rule. Okay, let's do another one. 2ab to the third to the fifth power. So this would be 2 to the fifth, right? A to the fifth and B to the 15th. And let's go ahead and take that constant and find out what 2 to the fifth is. What is it?
25.
No, 2 to the fifth.
Oh.
What'd you say?
32.
32. Yeah. That's what we found earlier, remember? It was 2 to the sixth was 64, so half of that is 32. A to the fifth, B to the 15th. Okay, one thing I just realized, which some of y'all may have done it, is that scenarios and functions worksheet. It has some of these problems on there. So I'm going to pass that back. It has these two that are those type of problems. Did y'all do those right? Yeah. I'll pass that back out. Let's go ahead and write the rule on here, though. When raising terms with exponents, to a power, multiply the exponents. Sorry, I was all over to the side. So the way we could write this is m to the a to the b equals m to the a times b. But this is different. Don't get this one confused with the one where we're multiplying like bases. So this is different from this rule. See how it's 2 to the a times 2 to the b, and we do a plus b. The reason is because you have a base on each one. The other one, you have the parentheses. So try not to get those two confused. So let's look at our slide. So you'll put a picture here, not right now, but whenever you get a chance. Now let's look at all of our rules now and fill this out. So these are our laws of exponent. Product of powers. When multiplying like bases, what do we do? Yep. So then this x to the seventh times x to the fifth is what? Yep, x to the 12. Do y'all remember how to do your exponent? What is it? Option or control greater than? Yeah. Okay, the next one, 4 to the third times 4 to the third. What will that be? 4 to the 6. When raising a power to a power, what do we do? Multiply exponents. So what will this one be? X to the 10th. Next one. Good. Power of a product. When raising a product to a power like this, a, b to the third power, what are we doing with that exponent? It's kind of like distributing. We are going to do the power of each factor. It's kind of like distributing, but how could we send the exponent to each factor? Yeah, it's like distributing. I don't think that's mathematically correct lingo. If you want to write that on yours, that's fine to help you remember. I'm going to write find the power of each factor and multiply. So each factor is like A is a factor of AB, B is a factor of AB. I'm going to take the power of each one, and then I'm going to multiply them. So AB to the third power will be what? A to the third, B to the third. Hopefully you can see that a little better. All right, the next one, we have m squared into the fifth to the fourth power. So what will that be? M to the eighth, because remember we're multiplying the 2 times the 4. And then what is in? Into the 20th. Yep. Let's look at the next side. A number or a variable to the power of 0. Is it? Let's look back at our notes. I know we wrote it down somewhere. Did we? I guess we didn't talk about this one. The 0 exponent is like if I have a 5 to the 0 power. 5 to the first power is 5, right? What's the coefficient of any number? It'd be 1. So anything to a 0 power equals 1. So 1. Okay. So anything to the 0 power equals 1. So x to the 0 is 1. 3x to the 0 is 1. Negative exponent. What do we do when we have a negative exponent? Where do we take it? Yeah, we put it to the bottom. So we do the reciprocal. Is the reciprocal? Reciprocal. So this one would be 1 over x to the 4th. And then this one would be x over 3 squared. Which would equal we got to take that square to each factor. So it'd be x squared over 3 squared, which would be 9. X squared over 9. The last rule, dividing like bases. When dividing like bases, what are we going to do with those exponents? Subtract the exponents. So on this one, we have 5 to the 6th over 5 to the 4th. So we would have 6 minus 4, 5 squared, which ends up equaling 25. The next one, 7 squared over 7 to the 5th, I need to subtract these exponents. 2 minus 5, what would that be? Yeah, 7 to the negative 3. Right, 1 over 7 to the 3rd power. There we go. Your assignment is slide 18, and you can do it in your journal and then take a picture. So these are all of the rules, all mashed up together. You will have time tomorrow to ask questions, though, okay?